Namaskar Mitrano. In today's video, we will take review of parallel circuits. Now we know whenever two resistances are connected in parallel, we are having some laws. That is, if you want to find equivalent resistance, we can directly use the formula R1 R2 divided by R1 plus R2. Or you can say voltage across this resistance remain constant, current get divided, and if you want to find current in any one branch, you can use the current division rule. It is applicable for two resistances in parallel. Similarly, we can use these rules for parallel circuit. If only two impedances are in parallel, we can use the same laws here also. We can find Z1 parallel to Z2 to get the total or equivalent impedance, and the formula is Z1 bar into Z2 bar divided by Z1 plus Z2 bar. But now we have to use polar forms for calculation. That means Z1 should be in polar, Z2 also should be in polar, and Z1 plus Z2 ची जी व्हॅल्यू येईल ती सुद्धा इन पोलार फॉर्म असायला पाहिजे. Okay, so if your Z1 is R1 plus JX1, we must have Z1 angle theta 1. If you are having Z2 bar as R2 plus JX2, you have to find Z2 angle theta 2. And if you want to find this denominator, you must have Z1 plus Z2 equal to R1 plus JX1 plus R2 plus JX2. Real part get added with the real part, which will give R1 plus R2. Imaginary part will get added with the imaginary part, X1 plus X2, and you will get finally in polar form as series ZS angle theta s. And you can put this here and you do the calculation. You know polar form is required for multiplication and division. So here we are multiplying Z1 and Z2. So magnitudes will get multiplied, angles will get added. If you divide Z1 into Z2 product by Z1 plus Z2, again the magnitude of this Z1 plus Z2, that is ZS, will make the division with the product, and angle will get subtracted. So इथे angle आला होता theta 1 plus theta 2, त्याच्यातनं हा theta s minus होईल. This is applicable for two impedances is parallel. Even you can find the current here by using current division rule. If you know the total current I flowing here, I1 is going here, I2 is going here, you can find I1 as I into opposite branch impedance. So I into Z2 bar divided by Z1 bar plus Z2 bar. So we can use similar law here, that is current division rule, to get I1 bar as total I but in polar form into opposite branch impedance in polar form divided by Z1 bar plus Z2 bar. Okay, so that is simple thing we have to do here, but this is applicable for only two. What happens if the impedances are more? That Z1 parallel to Z2, parallel Z3, Z4, like that. At that time, to use this formula is very difficult, and that's why we have to go for admittance method. Now what is admittance? Y is inverse of Z. So if you know the Z for that particular branch, you can find admittance by taking inverse of Z. So if I am taking only two impedances over here, Z1 bar and Z2 bar connected in parallel, so you can have Z1 as R1 plus JX1 or Z1 angle theta. Then how to find Y1? 1 upon Z1. So 1 upon Z1 theta 1. So it will give me Y1 minus theta 1. And if you split into rectangular form, this is a polar form. If you split into rectangular form, you will get G1 minus JB1. Similarly for Z2, you will get Y2 as a reverse, and finally G2 minus JB2. Z3, Z4, Z5 असेल तर सिमिलरली आपल्याला करत जायचं आहे, आणि ॲट द एंड तुम्हाला याचं इक्विव्हॅलंट फाइंड करायचं आहे. तर यू कॅन फाइंड YT just by adding Y1 plus Y2 plus Y3 like that. So real parts will get added with real part, imaginary part will get added with imaginary part. So G1 plus G2 minus J B1 plus B2. हा मायनस साइन आहे, जेव्हा Y मध्ये मायनस साइन आहे याचा अर्थ ते इंडक्टिव्ह सर्किट आहे, कारण इंडक्टिव्ह सर्किट मध्ये Z मध्ये पॉझिटिव्ह असतं, Y मध्ये निगेटिव्ह असतं आणि कॅपॅसिटिव्ह सर्किटमध्ये Z इज R मायनस J, पण ऍडमिटन्स जो आहे तो G प्लस J. ओके, सो प्लस साइन येईल जेव्हा कॅपॅसिटिव्ह सर्किट असेल. सो दिस गिव्स मी Y टोटल ॲट अन अँगल मायनस थिटा, आणि जर मला Z टोटल पाहिजे आता ह्याच्यावरनं तर 1/Y करावं लागेल. सो जो Y टोटल मिळालाय त्याला फक्त आपल्याला डिनॉमिनेटर मध्ये घ्यायचंय अँड यू विल गेट द Z टोटल अँगल थिटा. म्हणजे जेव्हा more than 2 impedances असतील, you have to use this admittance method, so that simply addition will give you total of this Y, and त्याचं रिव्हर्स घेऊन तुम्हाला Z डायरेक्टली मिळेल instead of doing such calculations. ओके, इथे तुम्हाला करंट फाइंड करायचं आहे. सपोज I1, you can use V by Z1 or V into Y1. जर ऍडमिटन्स वापरून करायचं तर यू हॅव टू मल्टिप्लाय विथ Y1. सिमिलरली I2 बार विल बी V बार बाय Z2 बार or V बार into Y2 बार. Okay, so by using this admittance method you can easily calculate the impedances in total impedances of the parallel branches. Okay, so in next video we will see numericals based on parallel circuit by admittance method as well as your impedance method. Okay, thank you.